Good morning, everyone. I am Miguel P. De Leon from 10 Einstein and will now be discussing to you the comparison of Boyle's law and Charles' law. Okay, this slide introduces gas laws. Gas laws help us understand how gases behave when pressure, volume, and temperature change. In this presentation, we will focus on Boyle's law and Charles' law, because they explain two important relationships that affect gas behavior in everyday situation and scientific experiments. Okay, so Boyle's law explains what happens to a gas when pressure changes while while the temperature remains constant. It states that pressure and volume have an inverse relationship. This means that if pressure increases, volume decreases, while decreases, volume increases. This relationship helps us understand why gases compress when pressure is applied. Okay, so now this slide shows the formula for Boyle's law, which is P1, V1 is equal to P2 and V2. This formula tells us that the product of pressure and volume before a change is equal to the product of pressure and volume after a change. As long as temperature is constant, we use this formula to calculate unknown pressure or volume values. Moving on to Charles' law. Charles' law focuses on the relationship between volume and temperature, while now the pressure is now kept constant. According to this law, volume and temperature have a direct relationship. This means that when temperature increases, the volume of the gas also increases. And when temperature decreases, the volume of the gas also decreases. Moving on to Charles. Okay, so the mathematical expression of Charles' law will be V1 over T1 and V2 over T2. This formula shows us how volume changes with temperature. It is important to remember that temperature must always be measured in Kelvin to ensure accurate results when using these formulas. Let's now get to the sample problems. So the sample problem will be a gas has a volume of 6.0 liters at 3.0 atm. What will be the new volume if the pressure changes to 2.0 atm? Okay, so the formula that will be used is, or the law that will be used is Boyle's law, which states that pressure and volume are inversely proportional. Okay, so first, I listed the given values. P1 is 3.0, V1 is 6.0, and P2 is 2.0. And V2 is our missing variable. So next, I use the formula P1. V1 is equal to P2 and V2. And then next, I substituted the values into the equation. After multiplying 3.0 and 6.0, I got 18. Then, well, finally, I divided it to 2 to solve for V2, and the answer is 9.0 liters. So now let's get to the Charles law. Always remember, Charles law rule is the temperature must be in Kelvin. And the formula will be V1 over T1 and equals to V2 over T2. So the problem will be a gas occupies 5.0 liters at 27 degrees Celsius. What will be its volume at 127 degrees Celsius if pressure is constant. So since the pressure is constant, we use the Charles law, which states that volume and temperature are directly proportional. First, I converted the temperature from Celsius to Kelvin because the formula always requires Kelvin. So step 1, 27 degrees Celsius becomes 300 K or Kelvin, and 127 degrees Celsius becomes 400 K or Kelvin. Next, I substituted the values into the formula V1 over T1 equals V2 over T2. The temperature and then we cross multiply. So after cross multiplying, I solved for V2 and got 6.67 and then liters. Okay, liters. Your evaluation will be the number 1. A gas occupies 4.0 liters at 2.0 atm. And what will be the new volume if the pressure becomes 8.0 atm? Temperature is constant. Okay. And the number 2 will be gas has a volume of 3.0 liter at 27 degrees Celsius. What is the new volume at 127 degrees Celsius? Pressure is now constant. Okay, so you know what to do.